This is question number 1 of homework 4 in capital budgeting. Consider the following cash flows on two mutually exclusive projects. So we have project A and project B. We have 3 years for both projects, and for each year we are provided with the cash flows. The cash flows of project A are expressed in real terms. So that means these numbers are in real terms, while those of project B are expressed in nominal terms. So that means the second column, these numbers are in nominal terms. The appropriate nominal discount rate is 13%, and the inflation rate is 3%. Calculate the NPV for each project. Do not round intermediate calculations and round your answers to 2 decimal places. So this is a very important rounding requirement. Do not round intermediate calculations. Many times, if you don't follow this rounding requirement, the answer you got may be different from the answer which is allowed in Connect. So this is a question on capital budgeting, specifically on calculating the NPV, but with the issue of inflation, which gives rise to the real cash flows, the real discount rate, and the nominal cash flows and nominal discount rate. And the key to solve this kind of problem is to realize that we need to be consistent. What this means is that we need to discount the real cash flows at the real discount rate and the nominal cash flows at the nominal discount rate. So in this question, we are told that the cash flows for project A are in real terms. So this column, the first column here, the cash flows are in real terms, and we need to discount these cash flows at the real discount rate. But the setup only tells us the nominal discount rate and the inflation rate. So we are not directly provided with the real discount rate. However, with the Fisher equation, we can figure out the real discount rate very easily. So if you go to the our SciCap website, go to the lessons, and we are at session 4, so just click on session 4, go to my required readings, the session 4 PowerPoint slides, click on that, and after downloading, open it. So you can see that here I just summarized the major points in each session. You can just go to the inflation and the capital budgeting. So I deliberately used the red font to highlight this is very important, be consistent. And the so-called Fisher equation means that links or the nominal rate with real rate and inflation. So 1 plus the nominal rate equals 1 plus the real rate times 1 plus inflation rate. So that means we can, once we know the nominal rate and inflation, we can figure out, we can calculate the real rate by this equation. So going back to our question, this information can allow us to figure out the real discount rate, and because the cash flows for project A are in real terms, so we can discount these cash flows at that real discount rate, and the cash flows for project B are in nominal terms. according to the setup here. And the nominal discount rate is already given, so we can directly discount these cash flows at this discount rate, the nominal discount rate. And then we can figure out the NPV for both projects. So that's the methodology to solve this problem. So now let me begin the work. Just open a new Excel. I prefer to use Excel because it's very convenient and powerful to use, and also because it automatically meets this rounding requirement, do not round intermediate calculations. So that's better than if you write the equation by hand and input the numbers into your calculator. Using Excel can help to solve this issue, rounding issue. So the first step is just simply to copy the numbers, into this Excel sheet. So let me see whether I can directly copy that. Oh, that's very good. So looks like I can just simply directly copy that to my Excel sheet, and nominal. So let me put the other information here. Nominal rate, discount rate. That's 13%. Nominal discount rate, 13%. So we can actually change this name to be NDIS, because later on I can just use this symbol to denote the nominal discount rate. And then inflation, that's provided as 3%. 3%. So again, I can just name this to be in INF, or maybe just inflation. Okay. So real discount rate. We can use this equation here. 1 plus nominal rate equals 1 plus real rate times 1 plus inflation. So let me write that number. 1 plus nominal rate, that's 13%, right? So 0.13. So this equals 1 plus real. Sorry for my very ugly handwriting, because I don't have a writing pad with me here, so I have to use my mouse, which is not very easy to use. Real. Let me just use some abbreviated. Real rate. Okay, for this, and then times 1 plus 3% inflation rate, 0.03. Okay, so then how can we solve out this? We can solve out this equation by dividing both sides by this 1 plus the inflation rate, right? And then move this to the other side. 1 plus real rate. equals 1.13, because 1 plus 0.13 is 1.13 divided by 1.03, right? 1.03. And hence, real rate. Actually, I don't rush to get this number because I want to follow the rounding requirement, not to round intermediate calculations. So I just keep the format as this. So real rate equals 1.113 divided by 1.03 minus 1, right? I just deduct this 1 from both sides so I can solve out this real rate. So that's basically this. So now let me put the right hand side into my Excel sheet, right? Going back to my Excel. So real rate equals 1.13 divided by 1.03 minus 1. So and I don't here I even though it looks like it's rounded, but in real calculations actually it's not rounded. So that's the that's the benefit of using Excel. So now I can name this to be real RDIS, real discount rate. So this is nominal NDIS, this is real RDIS. So then I can figure out MPV for project A. I can use the MPV function, MPV function. But remember, the MPV function actually, the values, you can see the second argument and the third argument, so on and so forth. That means the cash flows. Here, the cash flows, you have to start from year one's cash flow and leave the current or year zero's cash flows to separately. So I'll show you what I means, or what I meant. So MPV, first argument is the rate. So again, project A, the cash flows are quoted in real terms, right? In real terms. And we just solve out the real discount rate. So we just put this into as the first argument, and then the values 1, 2, and 3 zeros refer to the cash flows. As I said, we need to start from year one's cash flow and pull the mouse all the way down to the last year's cash flow. So C4 to C6. But then we are left out the first year, or the current year zero's cash flows is left out. So we need to add this current year's cash flows after we have done the MPV. So this gives us the MPV for project A. And then MPV for project B is similarly calculated, equals MPV. The rate here, remember project B, the cash flows are in nominal terms. So we need to discount these cash flows at the nominal discount rate. So the rate here, we have to use the nominal discount rate, and values 1, 2, 3, those again refer to the cash flows, and starting from year one's cash flow. So F2, F4, pull the mouse all the way down to the last year's cash flow. That means F6. And after we have done this, add the current year's cash flow. because you can see why I add, because the cash flows already has the no, actually I should this negative is in a different cell. What I should do is to add a negative here. So, and then again change this to be negative. Did that. So yeah, so now this is correct because the sign has to be with the number. So now I think we're getting the correct answers. Again, we have to follow the rounding requirement. Round your answers to 2 decimal places. So I have to change the format here. Right click on this cells and change, choose the format cells and numbers, and you can reduce this to 2, keep 2 decimal places. So the first, just copy the number. Project A is 37256.98, and project B is 401616.79. So now let me check my work. Okay, so it looks like we have got the right answers. So I hope that I've used this question as an example to show you how to solve the capital budgeting problems with the both nominal and real cash flows and both nominal and real discount rates. Again, the key is to be consistent. You have to discount the nominal cash flows at the nominal discount rate and the real cash flows at the real discount rate.